Okay, so this is how to write motion looking more like a math function. All right, so we have been writing it like this, which I would say looks very physicsy. Okay, but we can also write that in terms of a function. So x final is just a way to say the position at a certain time. Okay, and that would be more of like a function format that you might see in math. All right, so x as a function of time is the velocity times the time plus the x naught. All right, so whenever you see that, the first thing you really want to do is try to think about what are these numbers telling us. So when I look at this, I can see the negative 2t, that is the same as that term, and then the 4 is the same as that term. So before I even do anything, I can really see here that my velocity, assuming it's constant in this case, right, because it varies with the time, is negative 2 meters per second, and my initial position is 4 meters. All right. So then you can just use it and, you know, really just kind of by using math. We'll do more of this next week and the week after as we do more of the calculus of it. But remember, conceptually, you need to be strong in physics to do well in this class and also to do well on the test, right? The test is not as mathy as you think. My kids last year were like, oh, I thought it would just be like cranking out a bunch of math, but it's not like that. Okay, so you really need to think about what you're writing, all right? So if I have my function minus 2t. I'm just going to get rid of the 0.0, right? Because physics doesn't care about sig figs like chem does, really. Okay. What is the position, okay, as a function of time is 4 minus 2t. At what time does the particle cross the origin? Okay. So when the particle crosses the origin, that means the position is 0 meters. That would be the origin. All right. So xt, I'm just going to plug in a 0. 4 minus 2t. 2t equals 4. Okay, t equals 2 seconds. All right, so I can think about this if I was thinking of this in terms of a little motion map. I'm really big on drawing things. Okay, right? If I started at a position of 4, I'm losing, or I'm going in a negative direction 2 meters every second. So that happens at 1 second, and then another 2 meters at 2 seconds. Okay, so that's why I would get that. All right, so mathematically, that's how you would do it. What is the displacement of the particle between 3 and 6? So x final minus x initial. All right, so I'll have my position function. All right, and I'm just going to plug in a time of 3. Okay, so at 3 seconds, the position is 4 minus, what is that, 6, negative 2 meters. Okay, and at 6 seconds... All right, x6 equals 4 minus 2, 6 is 4 minus 12 is negative 8 meters. Okay, so 6 is my final time. So my displacement is going to be x final minus x initial, which is negative 8 minus negative 2. Okay, so that has gone a displacement of negative 6 meters. All right. Okay, let's look at another one. The position of a particle as a function as time is given by the equation x of t equals 6.8t minus 4.2. All right, so again, you should hopefully be looking at this and you can see here that the velocity is going to be 6.8 and the initial position is negative 4.2. Okay. Write an expression for the velocity of the particle as a function of time. Okay, so I'm not going to do the calculus this week. Okay, but if you know how to do that from calculus, you can just write the answer down. Okay, but this week we're just going to sort of think about it. And I know when I see an equation in this kind of a form, right, where the position varies like linearly with the time, that means the velocity is constant, okay? And by thinking about what we saw in the lab, I can see that this one is my velocity, all right? So we're just gonna write the velocity is 6.8 meters per second. Okay, again, calculus-wise, we'll do that in the next week or two, but if you already know it, go ahead and write it, okay? At what time would the position be 0 meters? All right, so again, we want to solve for the t, and we want the position to be 0. And we want to see when that happens, okay? So 4.2 equals 6.8 t. So t equals 8 divided by, should I be able to do that in my head? 4.8 divided by 6.2. Nope. 0.77 seconds. Okay? All right. And here, at what time would the velocity be 0? All right. That's sort of a trick question, because you should recognize when you look at this equation here that this equation is showing an object moving at a constant velocity of 6.8 meters per second. Okay, so the answer is never. The velocity is a constant 6.8 meters per second, assuming it's in meters. It doesn't really say, but let's just assume. Okay, all right, there you go. That's it, right? Yep.